Hello and welcome to our presentation on Foglight 5.9 AJAX and JavaScript features. Let's go ahead and get started with some use cases that we commonly see on e-commerce. And I'm picking on e-commerce because most people are familiar with things like the buying process. So let's start there. If you've ever been online and you're buying something, a computer for example, or a pizza, what you're doing is you're changing things as you go. So you're configuring that computer, you're configuring that pizza. And as you do that, you might add memory, you might take away memory, you might add a screen for your computer. And what happens is as you're doing these things, you'll see the price update in the right-hand column, usually in the right-hand column. And the same thing with a pizza. As you add different toppings onto that pizza, your price is constantly updating. But what you'll notice is it's not a full page load. So it doesn't ask for a new page every time you make a minor change to the configuration. And this is AJAX that's happening. So what AJAX is that means it's happening asynchronously. So it's not loading an entire page, but it's loading something inside of the page. Now besides that's more visible, those pieces that make the user experience a lot more friendly, you can also do this on the initial page load. Now the benefit here is there may be parts of a page that are slow. So if you have a performance architect working on a web page, what they may decide to do is put the banners or the iframes in an asynchronous process. Now the benefit of doing this is the page becomes active before those slow parts load. So the page can become active in 2 seconds, but maybe that banner ad doesn't show up for another second afterwards. So the big difference is once the synchronous part of the page is done, that page is active for an end user to start working on it. Now menus also happen. So a lot of people see these as you hover over an image or you click on something and it gives you some form of stylish drop down. These are also things that happen inside the page, again without being like the old web applications that used to ask for an entirely new page refresh. Now the reason I'm bringing these up is because there's a lot of difficulties with collecting information about what's going on with these asynchronous processes, and also there's a lot of difficulty with trying to diagnose problems when they do happen. So if you look at weblogs and Sniffer, the visibility is on the back end. And what I mean by that is you see it after something comes into the web server. You don't really have information about what's going on the client side. Now let's say that you click on a menu and that menu issues a call to the back end. Great, you see the back end call coming from that AJAX action, but usually it's some XML message, it's not a page. It's some XML message or some JSON call to your web application that really doesn't tell you what's going on. So you don't have the context you need to do anything about it when you do see it. Now the application agents have the same problem. They're on the back end and they're even a little bit more difficult because they only see calls that makes it to the actual application. And then if you use traditional web instrumentation, maybe you can do something to get the JavaScript errors, or maybe you could do something to get additional information about the buttons. But the big problem here is you don't have enough to give you context. So you still have to see the buttons and understand the page it came from, and then see the message maybe that fired off or didn't fire off. And that's what you need to give you the entire picture. So we're very excited in Foglight 5.9 because we're the first time we're bringing this information together for you in one interface. So we give you Java instrumentation details in addition to all of the web sniffer information we have. So with the web sniffer we're capturing everything, so we give you the best of both worlds and we unite that data together. And really the single data sets, the JavaScript information or the web sniffer information alone, it's good data and it gives you some information, but really the uniting of the two is what gives you this new insight that I'm going to show you very shortly. So our big benefit continues to be that we have 100% storage of everything all the time from the end user. So there's no missing evidence. The other big benefit of having every single response and every single request between the end user and the web app is that we have a place to park additional information. What I mean by that is we already have the page stored, so adding JavaScript information to that page so that you get context is very easy for us. Now, the thing that made this possible in 5.9, besides the 100% collection that we've had in Foglight, is that we get this really rich data set from our new instrumentation. So we get navigation timing detail, which became available as part of a standard to the web apps. But we also get DOM events and we get browser errors. So again, these errors are interesting if you're doing a standalone diagnostic, but in a production environment, we capture all of these DOM events and all of these browser errors so that we see which sessions they happened on. So without further ado, I want to jump into this live demonstration now that you have that context, and let's take a look at Foglight 5.9. So now that I'm loading in, I'm going to jump and we're going to start on what we call the Service Operations Console. The Service Operations Console lets you instrument an application. In this case, it's Ecom Ref Store, and then I'm on the Transaction tab. So this one I'm going to dive into pretty quickly because what we can see right now is on the ATG All Hits Transaction group, which is a group of basically HTTP requests. I broke this down also into categories. So there's several breakdowns you can do: categories, browser types, locations. In this case, I just picked categories, and I could see that 3 of my problems are on instrumentation. So let's go ahead, instead of clicking into all hits, let's filter out and just focus on our instrumentation. So now I do have some HTML hits as well, but my instrumentation has most hits, most problems that I have right now. So once I drill into that, I can see that there's, I can get the general timing, which is not that interesting because it's only instrumentation, but I also get my error counts, which is interesting because that's what I'm diagnosing. So I'll click on more details here, and what this does is it brings me all of the errors that happened over my entire time period that I had selected. And now I can go to the most recent instrumentation error, and what I'll do is I'll just pick the session, and we're going to jump right into this new window. So I already know that I'm getting a bunch of errors from AJAX, so I'm not doing any pivoting. But if we were traditionally coming in here, we would do a lot more diagnostics on that data set first. Okay, so now what I'm looking at is, this is my error that happened on instrumentation. And this is brought over, but I'm really not interested in that error. What I'm really interested in is the parent, the top page that error came from. So what I can do is I can go on and scroll up, and you'll see an HTTP request. And then basically what we do is reassemble that request so you can see what happened over time. Now, so now I have context. I have my error, and I have my context, which is my parent page. So what happened? Why do I have an error on that page with JavaScript? So if I click here, I can go into my client-side instrumentation details, and here is my information. So it tells me my window size, and then this says that you had a browser error, and it tells me the browser error happened because this JavaScript had a problem. Now this JavaScript happens to not fire anything off to the back end, so this is something completely invisible to weblogs and sniffers and application agents. So I had a problem on line 15, and my input node is null is the problem. So what I can do to diagnose this, I know exactly where it is. So what I'll do is I'll put in that JavaScript, and I'll go to line 15, or what I can do is I can do a search here on node, and that's not line 15. Yeah, so this is here, input node is null, right? That was our problem. So there is the line that's actually having the problem in that JavaScript. So I very quickly found a problem on my client side. I know the page, because I replayed it by reassembling all the hits off the wire. I know the page that it happened on. So this is a really good feature by marrying these 2 data sets together. Now let me go a step further and show you something really cool in this instrumentation. So besides all of the information I just showed you on the error, we have APM events. So these are things like the error and the initial information, which gives us the window size. But we also know all the navigations. We also know all the traditional browser events. So in this case, most of these are loading JavaScripts in my web app. So I could put all events here, and I can see over time, I can actually break down the series of loads on this page. And again, that's all coming from my instrumentation. So the marrying of the data set here is my response replay. It gives me basically my sniffer reassembly of all the hits, and then the additional instrumentation that comes in from the JavaScript. Now let's go back and look at one thing before we conclude. So if I go back up, and I'm just going to start from the beginning here because I know my home page loaded first. And what we'll do is we'll have a look at that home page, and we'll look at timings. So in this case, the timing wasn't a problem, but I just want to give you an idea. So our sniffer reported that this page took 765 milliseconds, and 572 milliseconds was spent in the back-end processing. Now what we have, by marrying the instrumentation data, I can come down here and I could see the navigation timing details. So the actual load time inside the browser is quite a bit different. It was 6.4 seconds. So this is very useful for things like Akamai. We also get DNS time, we get load time of the page, and SSL handshake time we'd get, and redirect time if those were actually seen on this page. So this concludes our presentation for today. I just want to wrap up by leaving you with some additional information about where you can call to get more information on this. So if you call 800-306-9329 or you email info@software.dell.com.